In this video, we'll cover a number of issues to understand before starting the creation of your elevated grayscale files. For instance, the inadvertent generation of walls and noise effects. The elevation process begins with your color image and adds a registered grayscale image which dictates the height of the color layer applied as the final layer in the print. Compare these two black and white images and note the differences. Understand what's happening in the right-hand image and why, keeping in mind black is the highest elevation and white the lowest. Most importantly, by default, a black and white image is not an elevation file simply because it has grayscale tones. With very few exceptions, it will not automatically work well as an elevation file. Now compare this final elevation print with the generated grayscale image. Note the correlation of the darker areas in the grayscale with the high points in the print. Before we get too deep into the process, it's important to review the issue of walls. Unwanted walls are an issue which arise with high contrast images, or rather, high contrast grayscale images. We'll start with an example image to illustrate a base of knowledge. So what we have here is a very basic color image, the color layer. What we need to do is create an elevation grayscale file to elevate these strokes here. The first step is to just simply turn the image grayscale. So there we go. Gray tones in light and dark, but we don't have a full black and a full white. For the Aries print process, we need to have a full black and full white pixel somewhere in every elevation image, no matter the final elevation. At this point, we don't have those here. We do have strokes higher than the background. We've done that. And the elevation here will be higher than this area here, which is also higher than this area here. So let's just change the contrast. And now we have full black, full white. But we don't have an even level of height on the whole stroke. But if we want these two strokes to have even height, then we need to edit this tone. The source color image is a good starting point to make a selection for an edit. With these two black strokes now generated, we have a full darkness down the whole stroke, and therefore at the same elevation. But there's still one more issue. The softness of this stroke will produce a smooth blend up from the base layer of the substrate to the highest point of that stroke. But here we have very high contrast from black to white. There's a very small amount of change over just a few pixels, and this creates what we refer to as walls. Here's a cross-section. This line here is our cross-section, and this is the end-on view. So what we have is elevation up from the base, and this volume inside this stroke here, and over here as well. This one is gradated. It's going up from white to black on a gradient slope. Over here, it's a very sharp change in height. The high point and low point between the two of them is very little distance across the horizontal plane. This will create these walls here, along the high contrast transition edge. Let's look at this in 3D. Here's the cross-section elevation from this two-dimensional image, the grayscale TIFF image, derived purely from the linear application of ink onto the surface. So here, with the pale gray tone, we get a low elevation, and here, with the black, we get the highest. Between the two is a very shallow gradation, very high contrast gradation, and with that, we're just creating this wall here. From the side, you really see the dark wall. There's a bit of color in the transition point at the top, where this gradation begins to flatten out again to black. But from a top-down view, the printer is doing a brilliant job of laying down the color in a linear direction from a two-dimensional perspective. But we're dealing with a 3D surface, so it's not going to hit this vertical wall here. That's the issue we're dealing with, and what we want to avoid by softening the contrast in the grayscale and elevation image. Softening like this will eliminate any possibility of a wall. The gradient here is smooth over a generous number of pixels, and the result is a smooth blend and no wall. Often, the color image is used as a starting point to generate a grayscale elevation file, or to add fine details in the sub-millimeter range. When this image is converted to grayscale, the orange of the ball becomes an undulating dark gray, with the gloss specular highlights staying white. If this grayscale image is used as an elevation file, These specular points, when surrounded by darker pixels, will become divots in the ball's surface. And conversely, these black and dark parts of the finger holes would spike up off the surrounding surface. In some cases, inverting the grayscale image will fix the problem. So in this case, inverting the image will turn the dark finger holes white, which is the beginning of what we want, but then the white highlights go black and we want a spike again. This can be avoided by cloning out the white highlights in the grayscale image, but no need to adjust the original color image. In this case, some editing is required to make these holes work effectively. A circular gradient in Photoshop will replace the overall curve of the ball. Layers on top will contain gradients masked to create finger holes. If need be, a 3D model can be aligned to render the correct gradient. So with this image, there's much to consider. When the color bricks and mortar are converted to gray tones, they work well as they are to create the appropriate elevated surface. The darker brick against the light mortar naturally provides enough contrast for low elevation details on an elevated print. Note that the spiky plants are not working and will need to be inverted to work well on a print. The dark areas here should be lower, but are instead higher, and the pale leaves here are pushed down in elevation. This needs to be isolated and inverted to work more appropriately. So, taking this grayscale version of the image and applying it on top of a base layer of bulk gradation will impart the subtle brick texture onto the walls of the church. Here are 3 identical images of a tree against a pale blue sky. Each column is 260 pixels or 2.2 centimeters. In the left column, the high contrast grayscale dark leaves and light sky elevation map results in black walls and a noisy surface. High contrast in the grayscale image over a few square millimeters can create an elevated spiky noise effect when printed. To remove this, blur the noise level pixels or lower the contrast on those small details. The center sample has had the grayscale elevation map blurred with a Gaussian value of 3. The result is less noise, but still has dark crevices with little color ink on these slightly slanted walls. On the right, Gaussian is set to 6 pixels, and now we see some of the pale sky color beginning to show as the black walls are further smoothed, drawing some green pixels down and blue pixels up, revealing the sky. A higher setting will fully bring back the color in the crevices and the sky to the elevated image. It's up to you how far you go in softening these edges. Careful use of masks and targeted blurring can soften high contrast areas while maintaining fine foliage texture details overall. Review the items outlined here and make note of areas that could cause problems with the image you wish to print. Check out other videos in this series for more details on how to start making elevated prints.